All right, so now we are on page 4. So we're going to start with number 37. It says solve for x. So what I'm going to do is get the equation by itself, set it equal to 0. So I'm going to subtract 15 from both sides. So x squared plus 2x minus 15 equals 0. And I'm hoping that I will be able to factor this. X times x gives me x squared, and then I need something that multiplies together to give me 15 that adds to 2, which is positive 5 and negative 3, which means x is either a negative 5 or x is 3. Number 38, I'm going to factor this just like I would factor number 37, except it's an x to the fourth. And so I'm going to start with an x squared times an x squared, because x squared times x squared does give me x to the fourth. And then I'm looking for something that multiplies together to give me negative 45 that adds to negative 4, which is negative 9 and a positive 5. So then I can factor the x squared minus 9 again. That's going to be x times x gives me x squared, and a positive 3 and a negative 3 gives me negative 9. So that means that I will have negative 3 as a solution. I'll have positive 3 as a solution. I cannot factor x squared plus 5, but what I can do, if I set it equal to 0, I can subtract 5 to the other side, and then take the square root of both sides, and so x is going to equal plus or minus I radical 5. And those are my 4 solutions. Factoring it would be the x plus 3, x minus 3, and then x squared plus 5. All right, let's take a look at number 39. We want to use the elimination method to solve this system, and so I'm going to try to figure out what variable would be the easiest to solve for. And I'm thinking the y's might be the easiest to solve for. I'm going to take the first equation and just multiply it times negative 1. If I do that, then I'm going to have a negative x and then a positive 3y and a positive 2z equals negative 2. So what I'm going to do first is take the second equation and this equation and add them together. So a negative x and a negative 3x is going to be a negative 4x. A 3y and a negative 3y, those are eliminated. 3z plus 2z is 5z. And then a negative 3 and a negative 2 is negative 5. So there's one equation with just an x and a z. So then I'm going to take the third equation and add it to my new equation that I got here. So I would have x and a negative x, those x's cancel. A 3y and a negative 3y, those cancel. 2z and a negative z, well that's just z. And negative 7 and negative 2 is equal to negative 9. So not only did my y's cancel out, but my x's did. That's kind of a bonus because now I know that z is negative 9. And if I plug negative 9 in for this z here, I'll have negative 4x plus 5 times negative 9. Well, that's minus 45 is equal to negative 5. Well, if I add 45 to both sides, I'll have negative 4x is equal to positive 40. And then if I divide by negative 4, x is going to be equal to negative 10. So now I have the x and the z. I'm going to go back to the original equation here. It says x, that's negative 10, minus 3 times y, minus 2z. Well, that's negative 2 and a negative 9, which is positive 18. That equals 2. And so negative 10 and 18, that's 8. So negative 3y plus 8 equals 2. If I subtract 8 from both sides, negative 3y is negative 6. And if I divide by negative 3, that means y is 2. Number 40, same kind of thing, except it's just a 2 system equation. If I multiply this equation here by 2, I'm going to get negative 2x, and then plus 6y equals 4. Now something weird happens here, because when I add these together on the left side, I get 0 equals 10. Well, that can't happen, which means this is no solution. Let's take a look at number 41. I want to get rid of all those fractions, so I'm going to multiply by the least common denominator, which I think is 12. I'm going to multiply everything by 12. So when I do that, 12 divided by 3, that's 4, so that's 4x, plus 12 divided by 6, that's 2, so 2x, minus 3 times 12 is 36, equals 12 divided by 4 is 3, so that's 3x. Well, 4x plus 2x is 6x, minus 36 equals 3x. I'm going to subtract 3x over here, so this is 3x. I'm going to add 36 to the other side. And then if I divide by 3, x is 12. Let's see what's going on here on number 42. rectangular prism with a square base has a height that is 2 inches or 2 units less than the length of the base, and the volume is 75. What are the dimensions of the prism? So it's going to look something like this. I have this square base. This is x by x minus 2, because it says that it's 2 units less than the length of the base, which means the volume is going to be x times x minus 2. Well, that's x squared times x minus 2, which is x to the third minus 2x squared. And they said that that is equal to 75. So I want to solve that equation. Probably the easiest way to do that is to take our calculators out and just type x to the third. So it's going to be x to the third minus 2x squared. Let me clear that. X to the third, and then minus 2x squared. And I can even go minus 75 if I subtract the 75 to the other side. And then when I graph it, I'm going to be looking for where it crosses the 0 axis. I'm going to have to change my window here. So I'm going to go from negative 10, let's go to 10 here, and we can count by ones. And let's say the minimum for y is negative 100, and I'm going to go up to 1,000, let's just say, and we'll count by hundreds and see what this graph looks like. I'm really looking for where it's equal to 0. And so I'm going to go then second. I'm going to go second and calculate. I want to find the 0. So I'm going to move my cursor to the left of this 0. And I'm going to move it to the right of the 0. And it is 5. And so that means that x, or the length, the dimensions have to be 5 by 5 by 3. Because it's 2 inches less, the height is. Number 43, it says solve this equation by finding the square roots. So I would start by dividing everything by 6, so x squared is equal to 10. If I take the square root of both sides, x equals plus or minus radical 10. Take a look at number 44. I'm going to solve this compound inequality and graph the solution set. So the first thing I'm going to do, I'm going to work up here, is I'm going to solve this equation. I'm going to subtract 11 from both sides. So I'll have 6x is greater than or equal to negative 25 minus 11 is negative 36. And if I divide by 6, x is greater than or equal to negative 6. If I do the same thing with this equation, I will have 10x. If I add 15 to both sides, then that means it's going to be is less than or equal to, that would be negative 20. If I divide by 10, x is less than or equal to negative 2. So on a number line, here is negative 6 and here is negative 2. It's greater than or equal to negative 2, but it's less than or equal to negative 6. Let's take a look at number 45. So Electronics Store makes a profit of $36 for every portable DVD player sold, and $36 or $63 for every DVD recorder sold. The manager's target is to make at least $252 a day. Then it says to write and graph an inequality that represents the numbers of both kinds of DVD players and that can be sold to reach the sales target. Let P be a player and R be a recorder. Well, for every player that I sell, I get $36. Plus, I get $63 for every DVD recorder. That has to be greater than or equal to a total of $252 every day. So then I want to graph this equation. So what I'm going to do, I'm going to consider this my x and the r my y. I'm going to make, instead of an xy chart, a PR chart. So I'm going to let the p be 0 and the r be 0. And when p is 0, I need to figure out what do I multiply 63 by to get 252. And so, let me clear all this. I'm going to take 252 divided by 63, and that's 4. And then if I take 252 divided by 36, that's 7. And so I have my two axes here. So I'm going to let this be the p-axis and this be the r-axis. So I'll have a point at 0, 4, which is 1, 2, 3, 4 here, and another point at 7, 0, 1, 2, 3, 4, 5, 6, 7, 0. I can hit the line, or I could be greater than that. So I would want anything up in that area. Let's take a look at number 46. It says solve this equation using your calculator to get the first solution. And so let's go ahead and do that. I'm going to go back to my y equals. I'm going to clear this. This is going to be x to the third power, and then minus 7x squared, and then plus 41x minus 87. And I'm just going to graph that. And again, I'm looking for where it hits the x-axis. That's a 0. Looks like it's going to be at 3. So let me just try this. I'm going to guess without really going to my calculator and finding it for sure. But if I put a 3 here, and this is going to be a 1x cubed minus 7x squared plus 41x minus 87. Let's just see if I get a 0 for my remainder. This is 1 times 3. That's going to be negative 4 times 3 is negative 12. Negative 12, or 41 minus 12, that's going to be 29. And 29 times 3 is 87. So that means this is factorable, and the factor is going to be x minus 3 is one factor, and the other factor is x squared minus 4x plus 29. So one solution is 3. My other solution is when this is equal to 0. So I'm wondering if I could factor this again, but none of the other solutions are real. So I'm guessing that I can't find something that multiplies together to give me 29 that adds up to a negative 4. So I'm going to do this by completing the square. So right now it's equal to 0. I'm going to go x squared minus 4x. I'm going to leave a space here. I'm going to subtract the 29 to the other side and leave a space there. That means I'm going to want to write this as x minus 2 squared. But if that's a 2, that means I have to add 4 to this side because that's 2 squared. And if I add 4 to the left side, I'm going to add 4 to the right side, which means negative 29 plus 4 is negative 25. So then when I take the square root of both sides, I'll have x minus 2 is equal to 5i, or negative 5i, because that's the square root of negative 25. So when I add 2 to both sides, I'll get 2 plus or minus 5i. And so my two solutions are 3 and 2 plus or minus 5i. Let's move on and take a look at number 47. It says a ball is thrown off the two-story building. The height of the ball is given by this equation where x is time and f of x is the height. When will the ball hit the ground? Well, when the ball hits the ground, that means the height is going to be 0. So that means I'm going to set that equal to 0. And it looks like I can make this a lot easier if I divide everything by 4. So I'm going to divide everything here by 4. That's going to be negative 4x squared plus 20x and then plus 5 equals 0. And so, let's see, I don't know if I can factor that. So what I'm going to do is, maybe I'll use the Pythagorean theorem, or the quadratic formula. So I'm going to go negative b, which is negative 20, plus or minus the square root of b squared, well that's 400, minus 4 times a, which is negative 4, times c, which is 5. And that's all going to be over 2 times a, which is 2 times negative 4, or negative 8. Well, inside the radical, I'm going to have 400 plus something because I have two negatives. So 4 times 5 is 20, and then 20 times 4 is 80. So this is going to be the square root of 480, which I'm pretty sure that I can simplify. That's going to be, let's see, 16 times 30. Is that right? 6, 12, 18. Yeah. 16 times 30. I can't break apart 30 anymore. And so I think they're looking for a decimal here anyway instead of a simplified radical. So I'm just going to plug this into my calculator and get my two solutions here. Or the other thing I could have done is just graph that equation and see when it crosses 0. You know, maybe I'll just do that. I'm going to go y equals, let me clear this. This is going to be x squared. Let me just do the whole, I'm going to do the whole original thing, which is negative 16x squared, and then plus 20x, and then plus 80x, and then plus 20. Now I got to figure out how to get rid of that squared. And start over. Okay. So you can see it goes up and it comes back down. I want to find that 0. So I'm going to go second, calculate. I want to find the 0. And so it's going to go up in the air, and then it's going to come down, and it's going to hit the ground at 5.238 seconds. 5.238 seconds. And that's probably what I would have gotten if I would have kept going with the simplifying of that radical. Let's move on. Let's take a look at number 48. Graph this equation translated 5 units down. Well, that equation looks like this. If I translate it 5 units down, it's going to look like this. Some of these questions are a lot easier than others. 49. I'm going to write this in factored form. So the first thing I'm going to do is pull out what they have in common, which is a 2x. That's going to leave me with an x squared plus an x minus 12. And then I have the 2x. I'm going to factor that factor. So x times x gives me x squared, and a positive 4 and a negative 3 multiply together to give me negative 12, but add to an x. So in factored form, number 49 looks like this. And then the last one on this page, solve the inequality and graph the solution set. So the first thing I'm going to do here is subtract 7. I'll have negative 3k is less than or equal to negative 6. If I divide by negative 3, then I'm going to have k is greater than or equal to 2 because the sign switches. So here's 2. It's a closed circle there, and I'm going to graph everything to the right. That is page 4, everybody. Hopefully that made sense, and we will go on to page 5.